as the global process of achieving carbon neutrality accelerates. And under the dual impetus of the grid resilience crisis, an energy innovation at the end of the distribution network has quietly emerged, from the Tibetan plateau to the deserts and global areas, from the African rainforests to the Andes mountains. Benchmark projects of leading enterprises such as Zijin Mining and Huawei, already in the mining area, successful implementation in off-grid island and industrial park scenarios, indicating a photovoltaic storage microgrid as an innovative form of distributed energy, form of organization. It is rapidly moving from concept to practice. The photovoltaic storage microgrid is centered around photovoltaics, demonstrate a strong vitality, integrating energy storage and intelligent control, small-scale self-made power system, and the broad application prospects. In business area, the photovoltaic storage microgrid can be used for factories and industrial parks, charging stations, commercial buildings, data centers, etc. Reduce costs in high energy consuming scenarios.
The emerging photovoltaic storage microgrid, thanks to its advantages in economy, environmental friendliness and scene adaptability, not only can ensure reliable power supply in a local area, but also aims to achieve a clean transformation of the energy structure. It can provide demand services such as peak valley arbitrage and backup power supply, as well as solve the multiple predicaments of power shortage and strong demand. With abundant wind and solar energy resources, but in the face of a weak power grid, the proportion of green electricity usage has increased. Emerging markets such as Africa, Latin America, and Southeast Asia are building a more resilient and intelligent future energy network, along with transformer capacity expansion. It is important to note that the impact of climate change extends beyond any single region or sector. Indeed, this global challenge demands cross-sectoral solutions. For example, the full life cycle cost of the photovoltaic storage microgrid in Indonesia's 500 kilowatt mining area has dropped by 77% compared to diesel power generation, vividly illustrating how sustainable energy models can address both environmental and economic imperatives. Another notable example is the Red Sea New City project in Saudi Arabia, where grid-connected energy storage technology serves as the core to achieve 100% green power supply, delivering over 1 TWh of annual electricity. This initiative not only verifies the technical feasibility of clean energy in desert environments but also sets a global benchmark for the transition to sustainable power, showcasing how regional projects can contribute to the broader fight against climate change. The project innovatively applies grid-forming technology and RTDS digital simulation to achieve multi-energy coordination of photovoltaic, energy storage, diesel generator and load, ensuring 24-hour continuous production of lithium extraction from salt lakes without main grid support. Combining the practices of Huawei and Zijin Mining, photovoltaic storage microgrids have achieved threefold breakthroughs in the technology business model, which can be replicated in 58,000 off-grid mining areas and desert regions worldwide. In the future, through the upgrading of VPP, virtual power plant, technology, mining microgrids will evolve into an integrated energy platform for production storage sale, boosting the zero-carbon transition in emerging markets. As a highland for China's energy storage industry innovation, Shenzhen enterprises can leverage their supply chain advantages to promote the export of photovoltaic storage microgrid equipment, localized production in mineral-rich countries, and the construction of smart energy scenarios in the Belt and Road emerging markets, thus seizing the global microgrid market share.